So what we'll be looking at today is what we call linear inequalities. We looked at linear equations the last time. Now we're looking at linear inequalities. Well, there are some similar features with linear equations and linear equalities, but the slight difference is that linear equations actually tells you that for the argument's sake, if you have x plus 4 is equal to 8, this tells you that this side is actually equal to this side. And so if we were to solve for the value of x, we would actually subtract both sides by 4, and x will be equal to 4. And so if you should take the value of x and plug it into x wherever x is on the left side of this equation, what we will get is 4 plus 4 is equal to 8, while the left hand side will be equal to the right hand side. But the concept of inequality is slightly different. What the concept of inequality is actually saying to us that there's a relationship between two expressions, and the expression can be, say, 2x is, let's say, greater than, let's say, 4. But what he's saying, well, 2x is less than 4. So what is he saying? This side is not equal to this side. So it is showing an imbalance, or something that is not equal. So it's showing the relationship between the two expressions on either side, telling you that they are not equal. So what there is just well, that's just a few specific digits, or it's like it's a limit, or there's a range of finite values that you can actually plug into this value x, where if we say x is actually the value of x, we will actually say we should divide both sides by x, and so x will be equal to 2. And so since x is equal to 2, well, let me not say equal to, was less than 2. So what this is simply saying, x can be 1.9999999999999 or 1.00111. But the thing is, it cannot be equal to 2. It's not equal to 2. So if x is actually from 1.9 go straight down to negative infinity, then this expression will actually be true. Because if I should try any number, if I should actually draw a number line and say 1, 0, 1, 2, 3, 4, and I say -1, -2, 3. Let us put our arrows to say it is continuing. What we just said, we just look at x is less than 2. So what we actually do to represent this on a number line, just to prove if this is true, or the statement is true. It's basically a statement to say 2x is less than 4. Is that true? Depending on what value is x, what are the values of x, would this expression be true? Well, would this inequality be true? So if I should actually say x is less than 2, so what I'll have to do, start at 2, and the direction that is going less than 2, so it's going into this direction. And so if that is the case, then we'll actually have to let it look more official. So what happens now? What this is saying, we have an open right there at 2, and it's going down to the right. And so all the values of x would be heading that side, but it is not equal to 2. So if we want to say, we can start from 1.9, go down. If you should actually plug 1.9 into this inequality and simplify to see if this is actually true. 2 times 1.5. Let's see if it's actually, let us see if this is true. If we should multiply 2 times 1.5, will it be less than 4? And so we want to look at that. So So this will give us 3.8. And if you look at it, this is true. So if we should pick any random value less than 2 and we substitute it into this inequality, when we evaluate it, we'll actually get a true statement that everything that we evaluate will be less than 4. And so that's simply what inequality is telling you. But let us go and let us try to recap on what are some of the symbols that we use in inequality. Now we have symbols like these, not equal. We have symbols like these. Right, I don't think they are anymore. So let's try to recap. How would you actually understand these? So let us try to do something simple, some basic examples. So if I have this one, and we say, all right, let's say 6. That's right, 6, and we say 7. Now what this is saying, remember when you have this inequality, and remember we normally use this analogy. If anything approaches the mouth of the lion, then we will say this thing is very great, it's brave. So we'll say anything that faces anything that is actually at the end of this inequality, we say it must be great. So it's actually greater. So and we look, and if any number or anybody that goes behind the lion and mocking the lion and teasing the lion behind him, he's a coward. So we say it's less than. So any number that goes here must be greater than the number that goes here. So this would make the statement true. This is actually saying 7 is greater than 6. So if we had something looking at this 3, this is saying 2 is greater than 3, which doesn't make the statement true. So once we have a number that is approaching the mouth of the inequality, that number should always be bigger than the one that is right here. And just flip to it. If we this is saying now 4, we say 5. Now this is saying, well, when you want to read it from left to right, but no, we don't want to try to read from this end. But you could say 5. We could say 5 is less than 4. This is what the statement is saying, but this statement is not true, because 5 cannot be less than 4. And so we actually understand how we deal with the less than and the greater than. Alright, so let's look at another one. But what we normally use is simply we use x's, right, variables. So we could say x is less than 7. So if x is less than 7, x can be 6.9999999, and it goes down 6.9. It could be 5, 4, 3, 2, 1, with all the decimals that you can think of. So we actually read this thing. So this is x is less than 7. And so if we should write another one like having this, we could say it's the reverse. We could say x is greater than 7. We normally read the variable first, and then we say the constant. Well, some persons will just read the constant and then read the variable. But sometimes when you read the variable first, what it does, it gives you a more picture or understanding of what the values possibly could be for x, or it could not be for x, because in this case x would be the subject. So you will see saying that what are the values of x, what x is greater than, or what x is less than. And so x would be like the primary focus right here. So we normally read x as the subject there. So let us look at another one. If we have x and we have this, so this is saying that x is less than, or, so it cannot be both. It has to be one out of. So we see that x is equal or less than 7. So we could choose any number that is at least 7 or less. So we could say if we should put 6 right here, this is where the inequality true, because this inequality could say it is saying that the value of x could be 6, it could be 3, it could be 2, it could be 1. So if we should read say 6 is less than 7, that would be true. So we could not say 6 is equal to 7. So we have to say it is either equal to 7 or it is less than. And in this case, it will be less than and not equal to. So it is an option, and depending on the value of the number. So if we had, say we had 7 representing x representing for 7. Well, this could be true because we could say 7 is equal to 7. And so we would not say 7 is less than 7, because logically that doesn't make any sense. And so as we go along trying to understand the inequality symbols, we are actually refreshing our minds, because we would have probably learned this in previous grades, like in lower school and so on. So it's just good to recap the mind as we actually go into linear inequalities, because linear inequalities are basically will be used as linear equations, but basically it is actually inequality, because it is telling you that there are certain values, or there's a certain limit, or there's a certain there's a particular variable that is equal to some set of numbers, and it cannot go over a certain boundary, and that makes it unequal. That makes it unequal. So if it were equal, then probably you just have just one number equal to one number. But inequality is not confined as if it were equal, because since it is inequality, it can have ranges of numbers, and then there's a particular number that it cannot go over, or it can go below. So let us try to look at inequality. What I call an equation of 4x plus 8 is equal to, no, not equal, but let's say what sign should I use? So we use less than 30. So we have 2. So what's happening now? We're actually going to solve for the value of x, just as if we had a linear equation. And so we're going to substitute this value for an equal sign temporarily, and then we solve for x. So what this is saying any value that we get for x, when we multiply it by 4 and add it by 8, it must be less than 32. So let us see what are the values of x, and then we're going to randomly pick any one of the values and evaluate that side to see if it actually less than 32. So let's go. We have 4x plus 8 equal to 32. And we just make x a subject, because that's what we want. We want to find what is the value of x. So x must be by itself. So if we should take away 8 from 32, we're supposed to go 24. Right, 24. And if we should divide both sides by 4, we will get, let's say, this looks like 6. So 6. So x is actually equal to 6. And so what we're going to do now is to draw the number line to represent the values of x from where it starts and from where it starts and where it is going. So if we draw a number line and we say 1, 2, well, we could just draw a 0 here. We could just say it starts at 6, so we could just put 6 right there, and we could just draw this blue line. It is not equal. X is not equal, or is not equal or less than. So see, if it's not saying that, then we just leave this open, and we go. It is what? Let me check it. It said x is what? Oh, x is less than 6. So is it less than 6? That simply means it is heading this direction, because it is less than 6, and it continues way down to infinity. And so we could pick any number that is less than 6 and plug it into the inequality and evaluate it and see if it is actually true. So let's go. Let us choose a number. We could pick 5.9. And so let us 5.9. So what here we had 4x, well, 5.9 plus 8, and this is saying this should be less than 32. So we're going to work that out. And so if we multiply that, we get let's say all of this will give us 31.6. And so if we should read this, would this be true? This is saying that 32 is greater than 31.6, or 31.6 is less than 32, and this is true. This makes the statement true. So let us look at another one. So if we are, say we have 2x plus 1 is less than or equal to 9. So making x a subject, we will write 2x plus 1 is equal to 9. 2x minus, well, let's say minus 1 minus that. So we can end up with x. 2x is equal to, this gives us 8. And if we should divide through by 2, we actually get x is equal to what, 4. But let us look at what was the inequality. It was in that it is less than or equal to, it's less than or equal to, so we actually write that. So we say that x, well, x is less than or equal to 4. So what this is saying, x is either 4 or it is less than 4, going down to infinity. So that's what it is saying. So let us draw a number line to represent this and to see if it actually works. So the number line, so look what is happening now. So if we have 0, see we have 4, 5, could actually have some negatives right here. It's a -1, -2, and it says that x is what? X is less than or x is less than or equal to 4. So since it is equal, then it will actually do something that is way different than the first time. So then we actually shade it if it is equal. And it is said it is less than, so it is heading in this direction. So we could pick any number from 4, since it is equal to 4 or less than 4. We could choose any number from 4 and below to see if it is right. So let us choose 4 and see what we got. If we should substitute 4 for x, we get 2 times 8 plus 1, and this gives us 9. So if so it will be true if we say 9 is equal to 9. But if we were to choose a number that is less than 4, like say 3, like say 2, let's say 2. If we pick 2, what we have we have 2 times 2 plus 1, and this will give us 5. But this will make it true just the same, because 5 is less than 9. So that is why we say it can either be that or that. So it can't be 2 at the